Today we'll study about law of gearing, which is also known as condition for correct gearing. Law of gearing states that common normal to the tooth profile at the point of contact should always pass through a fixed point called pitch point in order to obtain a constant velocity ratio. In order to prove this, let us consider two gears, the smaller gear known as pinion and the larger gear is known as a gear. The center of the smaller gear I have taken it as a point O1 and the center point of the larger gear is known as a O2. So let us consider these two gears will contact each other. Here I am taking the gear tooth of pinion and gear tooth of the gear. They are in contact with each other at this point. Let us take this point as a point Q. At this point of contact, let us draw a tangent. So I will call it as TT. It is a tangent passing through the point of contact. At this point of contact, let us draw a normal. So I have drawn a normal passing through the point of contact. Let us join these centers from O1 to O2. And this passes through the fixed point P called as pitch point. That is, normal has passes through this fixed point P always to keep the constant velocity ratio. Next, let us join, that is, let us draw a line perpendicular to normal joining the O1. So this is a perpendicular to normal which is joined to the O1. So let us call this point as a M, and similarly let us draw a perpendicular line to the normal which joins O2. I'll call this point as a. Next, let us join point O1 to Q and we'll call this angle as alpha. At the same time, we should consider the pinion is rotating in the clockwise direction. When the pinion is rotating in the clockwise direction, the gear will rotate in the anti-clockwise direction. And now let us join from O2 to Q. Now let us consider this point Q on the pinion, and when we consider the point Q on the pinion, the direction of velocity of Q will be perpendicular to O1Q, and that is given by QC. So QC, and the velocity component is given by V1. Now let us consider point Q on the gear, that is on wheel 2, and when we consider the point Q on the gear, the velocity is perpendicular to OQ2 and which is given by line QD. And velocity component is V2. Q1C makes an angle alpha, and these two angles alpha are equal because since O1M, O1Q are mutually perpendicular to QC and QN, and hence this angle alpha are equal in magnitude. Similarly, QD will make an angle of beta, which is equal to angle made by O2Q with O2N, that is angle beta. Now the two teeth to remain in contact with each other, the velocity components V1 and V2 must be equal along the Qn, that is velocity component V. The velocity component V1 and V2 should be equal along the normal, which is given by the velocity component V. That is, the velocity component of V1 along the normal is equal to V, and similarly the velocity component of V2 along the normal, common normal, is V. Now the condition is V is equal to, velocity V is equal to V1 cos alpha, which is equal to V2 cos beta. Now let us see what is V1. V1 is the radius into angular velocity. The radius is nothing but O1Q, which you can see in the figure. That is, O1Q is the radius. Similarly, for velocity V2, we have O2Q as the radius and angular velocity is omega 2. So here we have V2 is equal to O2Q into omega 2 is the angular velocity. Therefore, velocity V can be written as, in the V1 will substitute as O1Q into omega, and V2 will substitute as O2Q into omega 2. So V is equal to O1Q into omega 1 into cos alpha, which is equal to OQ2, that is OQ2 into omega 2 into cos beta. Now from triangle O1MQ, we have cos alpha is equal to adjacent side, that is O1M divided by hypotenuse O1Q, and from triangle O2NQ, we have cos beta is equal to adjacent side divided by hypotenuse, that is O2N divided by O2Q. That is, from triangle O1MQ and triangle O2NQ, we have cos alpha is equal to O1M divided by O1Q, and cos beta is equal to O2N divided by O2Q. Now substituting in the above equation, here we have O1Q into omega 1, and cos alpha is replaced by O1M divided by O1Q, which is equal to OQ2 into omega 2, OQ into omega 2. Now cos beta is replaced by O2n divided by O2q. Now O1q and O1q will get cancelled. O2q and O2q will get cancelled. Omega 1, this omega 2 will, when we bring on this side, so it will be on denominator. So omega 1 divided by omega 2 is equal to O2n, and this O1m will bring to the denominator on the right side. So it is O2n by O1m. Now we'll consider two similar triangles, O1MP and O2NP. That is triangle O1MP, and here O1P, you can see that it is again radius, so it can be O1P can be written as d1 by 2. It can be written as d1 by 2, that is radius of pinion. And from triangle O2NP, O2P is again radius of the gear, that is wheel 2. So this can be written as d2 by 2. That is the triangle O1MP, O1P can be written as d1 by 2, and from triangle O2NP, O2P can be written as d2 by 2. We have velocity ratio omega 1 by omega 2 is equal to O2n by O1m. Further, this can be now written as O2n by O1m is equal to d2 by d1, because 2 will get cancelled here, and d2 by d1 can be written as z2 by z1, that is number of teeth on wheel to the number of teeth on the pinion, that is on the gear to the pinion. Therefore omega 1 by omega 2 is equal to z2 by z1. Hence the velocity ratio is constant. So this is the law of gearing. Thank you.